if the data lined up like that, that would be strong negative feedback. So whenever people have done this work, they get different answers. This has led to uncertainty. A lot of uncertainty about feedbacks in the climate system, because how this data lines up determines what the feedbacks are in the climate system. So because the satellite data have been so ambiguous, the IPCC does not believe satellite data much anymore. The IPCC believes their models. Now, what I have discovered is that people have been misinterpreting the satellite data. They thought they were looking at feedback. Okay? They thought that they were seeing a relationship of temperature changes causing radiation changes. That would be feedback, this causing this. Okay? What they neglected to account for is radiation changes causing temperature changes. And you can tell the difference in the data by making phase space plots. This is where you take averages, 3-month averages every day, and plotting 3-month averages every day and connecting the dots with lines, and you can see how the system evolves. Okay? And when you do this, what you find is these stripes, and you also see some looping patterns. Okay? Now, it turns out you can use a simple model. We used a simple model to show that temperature causing radiation changes causes the stripes. That is the feedback. This is the signature of feedback. But radiation changes causing temperature changes looks like this. Okay? It's spirals. And in the real climate system, these two are mixed together. So when people have tried to estimate feedbacks, both of these things have been going on, but what we're really after is this. So it turns out, and we have a paper submitted to Journal of Geophysical Research on this, very long paper, because this has been difficult to publish, these results. But we have now very convincing evidence because we see it not only in the satellite data, but in the IPCC models. We have evidence from both the satellite data and the IPCC models that these stripes are the true measure of feedback. And that feedback, I won't get into the details, but this is the feedback number that we typically see from the satellite data. We see it from 2 different satellites. That number is very strongly negative feedback. To translate this into global warming, it would be about 0.6 degrees of warming by the end of this century. As I mentioned, I'm not going to go through this, but as I mentioned, we see this in the climate models too. This was a criticism of us, is, okay, well maybe this is the feedback. This is the criticism of our work, okay? Other people will say, okay, well maybe this is the feedback, but that's only 2 months, 3 months time period. Whereas global warming is 10 years, 50 years, 100 years, and maybe there's a different feedback occurring. Well, it turns out that in the IPCC climate models, the stripes also show up. This is the true feedback in the model, diagnosed by Forster and Taylor, published in 2006. And these are the feedback stripes we see from different models. The stripes line up along the true feedback diagnosed from the models. And that feedback there, that's the long-term feedback from carbon dioxide. Okay, this is the short-term feedback from natural fluctuations in the climate system. This is the long-term feedback from global warming in the model. And you can see that they're generally line up along each other. So this is evidence that the short-term feedbacks in the climate system are substantially the same as the long-term feedbacks associated with global warming. So as I mentioned, if this feedback number we get, 6, if that is really the feedback operating in the long-term global warming, it would only be about 0.6 of a degree warming, much below any of the IPCC climate models. So the satellite data suggests that the climate models have too much positive feedback, which then results in too much global warming, okay? And it's fundamentally just a mix-up between cause and effect. Temperature causes clouds to change, that's feedback. But also cloud changes cause temperature to change. I call that internal radiative forcing, just natural fluctuations in cloudiness. And we have 2 papers already published in Journal of Climate that discuss this evidence for negative feedback and also how clouds causing temperature to change gives the illusion of a sensitive climate system. It gives the illusion of positive feedback, when in fact negative feedback actually exists. Now, if I'm right, and we're only going to see 0.6 of a degree of global warming, or something like this, by the end of this century, what has caused the warming we've already seen? Because we've already seen at least 0.6 of a degree in the last century of global warming. What has caused it? Well, I believe, well, of course, there's theories about sunspots and things like that, and maybe that's part of what's going on. Could be. I'm not an expert in sunspots and solar variations. But one thing I do know as a meteorologist is that there are many things that control clouds. And all you would need is a change in circulation patterns on the Earth, atmospheric or ocean circulation patterns, and you could change the amount of cloud cover by a little bit. This is what the IPCC assumes does not happen. The IPCC assumes natural cloud cover on the Earth stays constant, decade after decade, century after century, which is totally unreasonable as far as I'm concerned. That is a huge assumption that they never mention. Okay, so what could have caused the warming we've seen? Well, what about natural cloud variations? The primary sort of long-term mode, or the primary multi-decadal mode of climate variability that we know about is called the Pacific Decadal Oscillation, or the PDO. Now this is not temperature, this is the PDO index. It's an index of weather patterns over the Pacific Ocean. The weather circulation patterns and ocean circulation like to go into either one mode or another. And it switches back and forth every 30 years or so. And people have noticed, before I didn't discover this, other people have pointed out that we were in the positive phase of the PDO during this period of warming. Okay, this is global temperatures from thermometer data, okay? People have noticed that we were in the positive phase of the PDO during this period of warming, the negative phase of the PDO during this, and then the positive phase again during this, okay? So I just asked the question, what if the PDO is actually changing global cloudiness, global average cloudiness, by a tiny bit?